Okay, so while the grid is being prepared, be a good time to just ask that you have your mics on the ready, because there'll be a couple of questions in the beginning. So I think the grid is had long enough. So it's lights out and away we go. Has anyone heard this phrase or this line before? I don't know where that's from.
F1.
F1. Yes, exactly. Just before they take off, the commentator always says, it's lights out and away we go. Okay, does anyone know what this is? While you're thinking about it, which will populate some more. Anyone know what these are? Or these?
It's a cars.
Cars, yes, they're F1 cars. They're all quite impressive F1 cars. And today, I want to talk about this one in particular, the Lotus 78, which was designed in 1977 and won like 5 world championships because of its amazing design. So here's a Lotus 78. Look at that beautiful looking car. Looks very different to a modern car, but it's still quite stunning. And here's a Swan. Lotus 78, Swan. Lotus 78, Swan. Car, bird. What's going on? There's actually a very interesting connection between the two. And so to begin explaining that, let's take a look at how you would design a car to go very fast. You would want speed, you'd want power, more power, you'd want less weight so they can go really fast, you'd want less drag so there's less resistance to go as fast as you can, and you can fly and zoom. And that's all well and good, apart from one thing, cornering. When you're going round a bend and you're turning really sharply, if you're going too fast, you've got too much power, you're just going to fly off the track. So when you're turning, you want to be as close to the ground as possible. You want grip. You want to be like glued to the ground. You almost want some suction. And that comes in the form of something called downforce. So if we look at cross section of a plane's wing, it looks something like this, where as the air goes over, because of the shape of the wing, we're going to get a bit technical here. Because of the shape of the wing, there's higher pressure at the bottom, lower pressure at the top, and that causes uplift. So that lifts the plane up. So if we want downlift or downforce, what do? We flip it. So now we have higher pressure at the top, lower pressure at the bottom, and that pushes the car down, or it pushes this wing down. So this is what engineers of the Lotus, or even before the Lotus, they started doing. They started putting these wings at the back of the car, and that would push the car down a little. But there was still a problem with that, because across the plane, across the wing, the air from the high pressure would try and travel down to the low pressure. You can see those little arrows there. Try and travel down to low pressure. And as the car going forward, that traveling there causes this spiraling vortex, and it just reduces the efficiency of that difference in air pressure, and so there's not as much downforce. So there's ways to get around it, and so what some of the teams did is they built these really longer wings, because then it's a lot longer journey for the air to go from high pressure to low pressure. Well, what happened was just loads and loads of accidents and all sorts of trouble, because they had these really long wings and everyone was just bumping into each other. So the FIA regulates all these rules for the design of the car. They said, okay, you have to make it shorter. So they were forced to make it shorter, and they came up with another idea, end plates. What end plates do is they make that traveling of the air from high pressure to low pressure just that much more torturous to go around. You can see in that picture there. But it still wasn't that efficient. Teams wanted more downforce. We're greedy, we want more downforce. We want to go faster. This is where our little bird comes in. Well, it's not a little bird. In fact, it's a big bird. These big birds, they're taking off. What they do sometimes is they dip their wing into the water as they're taking off, just the tip of the wing. And that has a very interesting aerodynamic effect, because that transfer of air going from high pressure to low pressure actually gets sealed off when that tip touch the water. It's got nowhere to go. It can't go from high to low. It gets sealed off completely. And so this is what car designers did with the Lotus 78. In fact, they decided to use the whole car as a giant wing. And it looked a little like this, where they've got at the bottom there something called a skirt. So all the air that's on top of the car now can't mix with the air at the bottom of the car. And I'm just going to pull up a little 3D model here, if I can. There we are. Hopefully that demonstrates things a little better, where you can see that there's something blocking the air from going from the top down to the bottom. And this is how we got our first downforce effect car. I can switch back to my presentation. There we go. This is how we got our first downforce effect car. And they were able to go really fast. And so we were back to racing. Super fast. Woohoo. And while this is quite an interesting little fun fact about birds in cars and how birds influence the design of the car, there's just a couple of things I want to mention. That is, one is when you look at your field, it's good to be multidisciplinary. So here we looked at the design of cars, and we can also notice that we looked at airplanes and we looked at birds, which are their own fields in their own right, and that all sorts of feeds into this field though. And so being able to expand your horizon and become multidisciplinary is something that can bring up your own field. The other thing is just to be inspired. We have all this nature around us, and they have a great many deal of solutions in them for us. And of course, we know we didn't create that. And there's something there if you were to really reflect. And with that, we finish. We come to the finish line. Woohoo! Race over.